Hello students of statics, this is Dr. Dan Baker, and today's video is going to be a first-hand view of how I use my hands to do the right-hand rule. First of all, these are my hands. I wear my ring finger or my wedding ring on my left hand, and so I'm always going to be using my right hand for the right-hand rule. Make sure that you're doing the same. Second, we can take a look and see that this is a right-hand coordinate system, X into Y, and I'm going to use two different types of cross products with my hands. One of those is going to be the slide then curl. If I want to slide then curl, if I want to cross X into Y, I need to rotate my hand around so my fingertips are in the direction of this arrowhead, sliding my fingers along X. I need to push them in the direction of Y. I need to curl my fingers, okay? So if I happen to turn my hand this way, my fingers don't bend up in this direction. So that doesn't work. I need to rotate my hand the other direction, rolling my fingers in the direction of Y. My thumb comes out of the page. Any thumb coming out of the page is going to be positive from the right-hand rule, okay? Thumbs up is positive, thumbs down is going to be negative. Okay, so that confirms this is right-hand coordinate system with the slide then curl. I'll also use a three-finger right-hand rule. Now there's two different ways to use the three-finger right-hand rule. For consistency, I am going to use, this is going to be the first vector that I cross, my index finger, number 1. This is going to be the second finger vector that I cross, number 2. And my thumb again is going to be the result of that cross product. Okay, so this one actually even takes a little bit more of a nimble hand. And so I'm going to line my first finger here along X. My second finger lines up along Y. And again, I get my thumb coming out of the page. Okay, that confirms that this is positive, a positive axis system, a right-hand axis system. And so let's go ahead and take a look now at a few points here on the page. And here is our force. Okay, we'll move this force around in different orientations. Let's start with this force pointed left, and we can assume it's along line AB. Okay, so if I want to take my moment around point O, and if we are taking cross products, what good is a force vector without a position vector? Okay, so we're going to look here at taking the moment around point O. So the blue vector is our position vector R. If we're going to use the slide then cross, slide your fingers along R, curl them into the direction of the force vector, right, which is going to the left. Turn my hand this direction, my fingers roll, my thumb comes out positive from the right hand rule. That would also be true if this force was coming out of B. I could slide this force actually anywhere along this line. This is called the line of action of the force. And anywhere along that line, I get the exact same moment around point O of this R crossed into this F, and it's going to be positive every single time. R crossed into F. Three-finger right-hand rule, let's go ahead and do this. First vector, second vector, so basically R vector, F vector, and moment vector. R, F, moment comes out of the page. Let's do another one. Let's go with a vertical force down here at D, still here reflecting moment around point O. So my R vector comes from O over to D. Takes a little bit more flexibility here. Slide then cross, slide. My force is going down, curl my hand, thumb goes into the table. That is negative from the right-hand rule. All right, the three-finger one here takes some flexibility. Once again, this is going to be R, this is going to be F, and this is going to be my moment. Okay, so first finger along R, second finger along F, that's coming downward. Thumb goes into the page, negative from the right-hand rule, just like our slide and curl. Let's do one more of these. Now, it turns out that you could also, say you have an angled force, you can actually look at the overall rotation which that angled force provides. Again here, we'll go out of point O. Now my R vector isn't quite long enough, but you can just imagine that it goes all the way from O to the line of action of that force there at B. Slide then curl, slide my fingers along R, curl them into that force. Even though the force isn't orthogonal, right, horizontal or vertical, I still get positive from the right-hand rule. With the three-finger R, F, R goes up this way, F comes up, thumb comes upwards, therefore we have positive from the three-finger right-hand rule as well. Now we could also do this from other points. Let's say that we're going to take some moments around point B, and if we put a force over here along OA, Then our R vector goes from B over to the line of action there at point A. So we can slide here. Now we have to roll our hand around in order to push our fingers in the direction of that force. Thumb goes into the page. Negative, 3-finger R. Our F here has to rotate around, so it's actually going up like the force is. Thumb goes into the page. Now there are many locations in a system where you'll actually have no moment from a force. Remember that a moment is the rotational tendency of a force. So given this scenario here, with the force still along AO, 2 of the 4 points have 0 moment from this force. Go ahead and guess what those 2 points are. Shouldn't be a guess, you should know what those are. Turns out there's no moment around point O. I could slide this down here if I wanted to. Basically, my R vector is 0. Same thing if I slide the force out to point A, my R vector is 0. So I'd only have a moment around B and D. And as we found, from B, it's going to be negative from the right-hand rule. And also from D, it's going to be negative from the right-hand rule. Okay, so your moment can either be positive, negative, or also 0. Hopefully this helps, this quick video to show you how we use the right-hand rule, either with our slide and curl, or 3 fingers, R cross into F is your moment. This one would be that direction right there. Thanks for all your hard work.